Okay, in this question, we need to find the sample mean, variance, and standard deviation for a data set that's given. So first notice that what you're given here is, what you need to find is a sample mean, variance, and standard deviation. For a sample, the formulas, at least for the variance and standard deviation, are different from the formulas for a population variance and standard deviation. I will talk about this when we reach variance and standard deviation. But for the sample mean, the mean, we just use a different notation for it. So the sample mean, we call it x bar. And this is equal to, you sum all your data, the sum of all the data x over the total number of data n. In this case, if you do this, you will be adding these numbers in the data set, add everything, and divide by the total number of data. If you count the total number of data that we have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you will be dividing by 12. Okay, so this will be 18 plus 24 plus 32 plus, I will put dot 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 until we reach 68 plus 74, the 12 numbers, divided by 12. And if you do this, you will get 46.4 rounded to 1 digit. And just remember, there is a rounding rule. We are using the rounding rule for the mean. And it's also the same for the variance and standard deviation. Is you look at your data don't have any decimals, they are whole numbers. So you do 1 digit, 1 decimal more than your data. If the data had a decimal, then the mean and variance and standard deviation will have 2 decimals. So you round them to 2 decimals. In this case, 1 decimal, because the data did not have any decimals in them. So therefore, this is our sample mean. Now, let's go to the variance. There is a formula for the variance, and also for a sample, the sample variance, we denote it by s squared. So the computation is also simple. S squared, the variance, is the sum of the data values minus the mean that we just computed in the previous page, squared, divided by the sample size minus 1. And this sample size minus 1 is because we have a sample. If you have a population, you will not use n minus 1. You will just put n if it was a population. And the question will tell you if it's a sample or a population. So let's just erase the population. Just remember this fact. And so if you do it here, you'll be summing all the data values. The first one is 18. Subtract the mean from it, which we calculated here. The mean is 46.4. So 18 minus 46.4 squared, plus the second value is 24, minus the mean is 46.4 squared, plus go all the way to the last value, 74, minus the mean, 46.4 squared, and divide by n minus 1. Remember that our n in this case was 12. We have 12 values, which means that n minus 1 is 11. So this is why we will divide here by 11. And if you do it, you'll get 310.3, rounded again to 1 decimal, because our data don't have decimals in them. Again, I will remind you, if our data had decimals, then we would round this to one more decimal than our data. Our data are the values here. The last and easiest one is the standard deviation. The standard deviation, S in this case, because we have a sample, the standard deviation is just the square root of the variance. And the variance was just computed. It was the S squared that we computed on the previous slide. So this will be the square root of, let's see, what was it? It was 310.3. So I'll put 310.3, and again I will round to one decimal, so this will be 17.6. This will be our standard deviation. But just remember that this is our sample standard deviation. It's very important that you remember. And this also here is our sample variance. And the first one that we computed was our sample mean. For mean, it doesn't matter. There is no difference between the population or sample. But for the variance and standard deviation, what you will do is the number that you see here is n minus 1. For a population, it would be n. And for the standard deviation, of course, it's the same. This would be n if it was a population. And remember, for a population also, instead of x bar, we call it mu. This is if this is for population, and this is for the sample. And for the sample, we call the variance S squared, but for a population, it's sigma squared. I don't mean here equal. They're not equal. I mean, they're not equal, but I mean what they mean for each one. This one is for the sample, and this one is for the population. And the last one is that we use S for the standard deviation, and we use sigma for the population. So the S is for the sample standard deviation, and sigma is for the population standard deviation. And remember, again, this is not really equal. It's just, I'm telling you that what letters do we use. And I will end this video here.